proportion. Ratio, proportion, and variation. A ratio of one number to another is the first number divided by the second number. So the ratio of A to B is A divided by B. And when you have ratios, you need to make sure that you have simplified them. Let's look at an example. Number 4, we have 5 to 45. So this ratio is 5 over 45. And we don't leave it that way. 5 goes into 5 once, 5 goes into 45 9. So this ratio is 1/9. The second one, we have 60 to 15. That's not in its simplest form. 15 goes into 60 4 times. 15 goes into 15 one time. So that ratio is 4 to 1. Now, in the previous problem, notice that we did not have any units on our ratios. But when you go to compare and put something as a ratio, you need the exact same units. For example, number 12, we have 50 watts to 16 watts. So that's 50 to 16, which reduces to 25 over 8. And notice that since we're using the same units, we don't have to worry about putting them. However, number 16 is a little bit different. We have 500 pounds to 3 tons. Now we know that we can measure weight in both pounds and tons, but we need to get these to be the exact same units. So 500 pounds, 3 tons. So we go and we talk about, what we do here. We did this, I think, in the last chapter where we had those unit multipliers. We know that there are 2,000 pounds in 1 ton. So since there are 2,000 pounds in 1 ton, 3 tons would be 6,000 pounds. Okay? And this is not times, this is equal. We just converted 3 tons to 6,000 pounds. Now, since we have everything in terms of pounds, we can cancel the pounds out, and 500 over 6,000 reduces to 1 over 12. So you have to be very careful with the units when we're talking about ratios. Now, we want to ease into proportions. A proportion is a statement that 2 ratios are equal. Now, I do want to make the statement. A over B is a ratio, C over D is a ratio. The A, whatever unit is on the A, should be on the C. Whatever quantity you're letting the numerator be, it's going to be the same quantity in both numerators. Whatever quantity represents in the denominator, it needs to be the same. So if you had inches over feet or inches over something, then in the numerator on the other side you need inches over whatever. Okay? We're going to start off by solving a few simple proportions. And to solve proportions is basically cross multiplication. We have x over 3 equals 7 over 12. So when we cross multiply, 12x equals 21 divided by 12. This is called multiplying the means by the extremes. But basically it's cross multiplication. X is going to be, when we reduce this, 7. Over 4. We reduce 7 over 4. The next problem is 8 over 15 times times x over 9. So 15x equals 72. So x is 72 over 15. You always want to reduce these fractions. 24 over 5. You always want to reduce the fractions. Now we talk about ratio and proportions in terms of problems with words, word problems. So let's read what it says. The ratio of a number to 15, so let x equals the number to 15, is the same as the ratio of 17 to 60. Find that number. So when I multiply, 60x equals 17 times 15 is 255. So x is 255 divided by 60, and we know that's not in the simplest form, but its simplest form is 17 over 4. All right, another problem says a stock priced at $120 per share and annual earnings average to $8 per share. What is the price to earnings? A stock is priced $120 per share. Okay, and annual earnings average is $8 per share. What is the price to earnings? So the price per share is $120. The annual earnings average is $8 per share. So we reduce this. 15 over 1 is that ratio. So this was just a ratio. It wasn't a proportion, just a ratio. Next one, number 42. Says a truck can go 245 miles on 35 gallons of diesel fuel. How much diesel fuel will be required to go 1,250 miles? So it says we can go 245 miles per 35 gallons. So when we set up this proportion, the number of miles needs to go in the numerator. How much diesel fuel, we don't know, but we represent the fuel in the denominator, will be required to go 1,250 miles. That needs to go in the numerator. Remember, whatever quantity you have in the numerator on one side needs to be the same quantity in the numerator on the other side. So when we cross multiply, we have 245x equals 43,750. So when I divide, I get 178.6 gallons. And here, you know, they did not say to round. They didn't say anything. But this is about 179 gallons. All right, so that's ratio, that's proportion. The next topic we're going to talk about is variation. So we know that variables can take on different values. Generally, though, a constant would take on one value. So when we have this relationship y over x equals k, y and x are considered constants. K or C is also used as a constant. Now if we solve this, we have y equals k times x. This is the formula for direct variation. This equation can be interpreted as y is proportional to x, or y varies directly as x. So what we're going to do, we're going to do a couple of problems where we just translate the English statement to an algebraic statement, and then we're going to do one where we actually solve to find this variable k. Number 48 says they want us to translate this from an English statement to an algebraic statement. X varies directly as x means that x equals some constant k times s. That's all they want us to do there. Translate that statement English statement into an algebraic statement. Number 50, same way. S varies directly. So S equals K as the cube of T. So you write S equals K T cubed. So it's not so hard to translate the English statement to an algebraic statement. Let's look and let's see what happens. Number 66. They want us to find y when x is 5 if y varies directly as x. So y varies directly as x means y equals k times x. Now, that's the first step. But a problem like this, we need to write the equation. Number 2, somewhere they should give us values to find k. And from that we can write a general equation, or no, a specific equation, specific for the k we just found. And then number 4, we need to solve the problem. So we have y equals k times x. Y varies directly as x. And they tell us y is 36 when x is 2. So here they're giving us this to give us a means to find k for this specific problem. So k, if I divide both sides by 2, is going to be 18. K is going to be 18. So now I can write my specific equation, y equals 18x. This is my specific equation. And now what they want me to do, this is the ultimate answer, find y when x is 5. So y equals 18 times 5, which is 90. This is the answer they were looking for. Number 1, there should be an English statement that can be translated to an algebraic statement. Number 2, they should be giving you means to find k. They gave us an x and a y so we could find k. So we got our specific equation. And then they wanted us to find y when x was 5. Now that's direct variation. There are other types of variation. Another one is inverse variation. You may see something like y varies inversely as x, or y is inversely proportional to x. What that means is y equals k divided by x. So again, let's translate this English statement into an algebraic one. Y varies inversely as the square of x. So y equals k over x squared. Y equals k over x squared. And then this next problem is similar to the previous one we did. It says find y when x is 6. If y varies inversely as x, so y varies inversely as x, means y equals k over x. And they give you that y is 15 when when x is 3. So when we solve for k is 45. So my specific equation is y equals 45 over x. Y equals 45 over x. And then they wanted me to find y when x is 6. So we can reduce this to 15 over 2. That is inverse variation. Another type of variation is combined. It can combine direct, inverse. It can combine it all. So let's look at number 56. Y varies directly as S. Remember, now you only put one constant K in here, but directly is next to it, multiplied together. And inversely is in the denominator. Inversely as the square of T. That's what that means. Y varies directly as S. You multiply. Inversely, it puts it in the denominator. Now, as I said, notice we're only using one constant of variation K. So, let's look at a problem. It says S varies directly as the square of V and inversely as T. So, S varies directly as the square of V and inversely as T. Okay. Now, we know that S is 27 when V is 3 and T is 1. So we have 27 equals K times V squared over 1. So 27 equals 9K. So that K equals 3. So our specific equation is S equals 3V squared over T. Now it says find S when V is 9 and T is 3. V is 9 and T is 3. So this cancels. S is going to be 81. S is going to be 81. Now we can also have some application problems when dealing with variation as well. Let's look at number 74. It says in chemistry, the general gas law states that the pressure P of gas varies. P varies directly as the thermodynamic temperature T and inversely as the volume. Express this statement as a formula. But they also tell us a constant of proportionality is called R. So P is RT over V. P is RT over V. This is the first one I've seen where they actually tell us exactly what letter to use as a constant of proportionality. Make sure that on your online homework you're reading so that you're inputting the correct variables. Last one. The heat loss through rock wool installation is inversely proportional to the thickness of the rod wool. So heat loss is inversely proportional to the thickness of the rod wool. Now you can use, whatever variables you want to use here. Doesn't matter. It says, if the loss through 6 inches of rock is 32, I don't know, I believe this is butane per hour. I'm not sure what BTU is. Find the loss through 2.5 inches of rock wool. So they give us that 6 inches, that's the thickness. And they give us the heat loss as 3,200. So K is going to be 6 times 3,200, which is 19,200. So our specific equation is H equals 19,200 divided by W. Then it says find the loss H through 2.5 inches of rock wool. So 19,200 divided by 2.5 gives us 7,680. All right, this is a brief discussion on ratios, proportion, and variation.